This is a pre-built version of the application. So let's go ahead and run it, and we can pick up data from one of three places, either from the database or from file, or we can pick up hard-coded data. And we can run the application in verbose or in default mode. So let's pick up data from file, and we can pick it up from one of those three files, JSON files, and we have them here. So we specify here the outbound flight and the inbound flights, and the name of the trip. So let's say we are going to pick up this airline. So we suppose that this fly-by-night airline did some type of research and determined that those trips will be the most popular, so at those times. So we have the outbound flight leaves at this time and lands at this time and stays on the ground for this number of minutes, and then it comes back at this time and lands at this time and stays on the ground this number of minutes and is ready afterward for another trip. And here we have all that in JSON format. Same for the other two fly-by-night airlines. So the goal is to determine what's the minimal number of planes that can be used to achieve this schedule. And this is the domain, so we can either use 3 planes, 4, 5, or 6 planes, and we can add or remove any one of those items. Same thing for here. For the airlines, for the JSON files, we can add or remove any one of those. So let's go for 3 planes. And we end up with this concurrency table. So this trip from 12 to 18, the concurrent trips for that are those other trips, and this one has those concurrent trips, etc. So here, this one, we're talking about this trip. So we generated this concurrency table based on the timings on those trips. So those are the constraints that we have. This trip must be assigned a different plane from this one must be assigned a different plane from all those trips. Same for this one and this one. And this is the information that we have. So the implicit constraints is that adjacent variables must have different values, and the variables here are the trips and the values are the planes to be assigned to those trips. and the domains are the values that are allowed. In this case, we have 3 planes that are allowed to be assigned to those trips. And the solution will have a list of variable equal value satisfying all constraints. So here we are using the backtracking search algorithm. So depth first search, and we consider assignment to a single variable at each step, and we consider only values which do not conflict with previous assignments. So let's go ahead and do that. So we assign this trip to this, or we assign this plane to this trip, and none of the concurrent trips are assigned the same plane. And we assign this plane to this trip, and none of the concurrent trips are assigned that same plane, etc. And we can do the same thing, but pick up the data from the database. But before we do that, let's go ahead and create that database. So here we have the 3 fly-by-night airlines with their outbound and inbound flight timings, and we call all 3 from here. So let's go ahead and run this, and refresh here. So this is the database that we just created. So now we pick up the database and maybe use this airline, and it has those 7 trips based on its market research, and so we want to determine the minimal number of plane to serve those trips. So maybe 4 planes, and this is a concurrency table that we generate. So those trips are concurrent to this trip, and same for those. They are concurrent to this trip, etc. And those are the constraints. So this trip must be assigned a different plane from all those trips. Same for this one, etc. And same thing, this is the information here, and here we have 4 planes. And let's do the backtracking search. So this plane was assigned to this trip, and none of the concurrent trips were assigned the same plane. Same here, etc. And for data coming from the database, it comes from this file. So here we're hard coding the outbound and inbound flights, and the name of the trip, each one of those trips for this airline, and same for the other 2 airlines. So if we do hard code it, and maybe use this airline. So we have 9 trips here. And we'll try to do it with 6 planes. So this is a concurrency table, and those are the constraints that were generated. And let's do the backtracking search. And here we go. And we'll quickly go over the classes that we have here. So this class contains list of trips or round-trip flights operated by various airlines, and it contains lists of domain values or planes to be used. And this one here, we create and populate the table for each one of the fly-by-night airlines. And this class prompts the user for a file, table, or hard-coded data source, and it prompts the user for domain and variable selection, and it picks up and return a map containing variable flights and their concurrent flights. And this class represents a flight including takeoff, landing, and time on the ground. And this one represents a round trip including outbound and inbound flights. And the code includes logic to check if 2 trips are concurrent. And this class contains code display functionality, so it displays trips or round-trip flights, initial data, initial information, solution, and derived list of constraints and variables, and the constraints and the variables. And this class represents a variable, meaning a flight in this case, and it keeps track of a list of concurrent variables or round-trip flights, and it keeps track of a list of derived constraints associated with this variable. And this class represents a constraint between 2 concurrent variables that must use different values or planes, and it contains logic to check for this constraint. And this class contains constraint satisfaction problem, flight scheduling logic, and it keeps track of a list of variables and domain values or planes to be used, and checks if plane assignments are compatible with constraints associated with all variables or flights. And it uses the recursive backtracking search algorithm for domain values or plane assignments. And finally, this class drives the application and uses the recursive backtracking search algorithm to find a CSP solution. Now the source code will be available for download, also a members only version including step-by-step coding, will be available for viewing by channel members at the senior software engineer level and above.